All right. Looks like we're doing Trig lecture 10.4 and 10.5. Student will find the reference angles for angles of rotation in standard position given degrees or radians. We'll take a look at what that means. First of all, we'll define the reference angle. The reference angle is an angle that's formed by the terminal side of an angle that's in standard position. That's where the positive x-axis is the initial side, as we've talked about in the past, and the angle rotates positively or negatively. And the angle that's formed by the terminal side, wherever the terminal side stops, and the nearest x-axis, that's what we call the reference angle. So we're going to try to find reference angles. So here's what this looks like. Notice this is the nearest x-axis. Let's look at this angle right here, 600 degrees. It's sketched in advance for us. And let's just follow this rotation, see that it is 600 degrees. It's going in a positive direction, as is indicated by this little loop-de-loop thing here. All that does is indicate the direction of the rotation. This rotates 180 degrees, then 360 degrees, 450, 540, and then I go to 600, so I'm going to have to go from 540, I've got to go another 60 degrees. So this angle from the negative x-axis to the terminal side is 60 degrees. Now we're looking for the reference angle. The reference angle is formed by the terminal side and the nearest x-axis, not the y-axis, the nearest x-axis. Well, here's the negative x-axis, here's the positive x-axis, here's 0, the origin. All of these values on the x-axis are positive, all these values are negative. The nearest x-axis to this terminal side is the negative x-axis. So the measure of this angle right here is what we're talking about. This is the reference angle. We rotated 600 degrees and stopped here. The reference angle is the measure of this angle right here. And as we just came to realize by counting our rotations, from here to here had to be 60 degrees. Let's run through that again. Here's 180, 360, 450, 540. I'm just adding 90s every time I rotate another 90 degrees. So 360, I've rotated all the way around, 450, 540. To get to 600, I've got to go another 60, and the angle formed by the terminal side and the nearest x-axis, in this case it's negative, the negative x-axis, our reference angle is 60 degrees. The reference angle is never negative, just the direction of rotation can be. Okay, and there we go, that's what we're going to be doing. Let's do one here, we're not given a drawing of it, so I'm going to do my own drawing. Just a quick sketch to give me an idea what this thing looks like and to determine the angle formed by the terminal side and the nearest x-axis. So here we go, this is the y-axis, this is the x-axis. It's kind of a sloppy drawing, but we're going to rotate. Here's our initial side. We're going to rotate negative 200 degrees. That means we're going to be rotating in a clockwise direction. Here's 180, negative 180. I've rotated like this. I've got to go another 20 degrees in a negative direction to get to 200. So it'd be something like this. That's probably a little bit big, but this is just a rough sketch. And we're talking about the measure of this angle right here between the nearest x-axis. It just so happens that's a coincidence that it's the negative x-axis again. It's just this angle is closer to the negative x-axis than it is the positive x-axis. So we're talking about this angle right here. And its measure would have to be 20 degrees, because to rotate from here to here is a rotation of negative 180 degrees, and then to go even further and stop at 200, negative 200, we'd have to go another 20 degrees. Remember that the measure of the reference angle is always positive despite the angle of the direction of the rotation. This plus or minus just is determined by the direction of the angle of rotation. The direction of the rotation. So my reference angle here would be 20 degrees. the angle formed by the terminal side and the nearest x-axis. Let's take a look at another one. This one is in radians, so I'm going to go ahead because most kids like to convert to degrees. Later on I'll show you how to count in radians, rotate in radians. But right now we'll just go like this. I'm going to multiply by 180 over pi and convert it to degrees. You can do this with your calculator if you want to. These will cancel. 9 and 180 will cancel. That turns into a 1 and this turns into a 20. I'm dividing both of these by 9. All that I'm left with is 25 times 20, which is 500 degrees. So I'm going to rotate 500 degrees. And it's already drawn for me. Rotating in a positive direction, there's 180, 360, 450. If I'm at 450 right here, how much further do I have to go to get to 500? Well, this right here would be 50 degrees. This is not the angle we're looking for. This is not the reference angle. The reference angle is formed by the terminal side and the nearest x-axis. And again, it's just by coincidence the negative x-axis. If this is 50 though, this one has to be 40 because this is a 90-degree angle. So my reference angle, formed by the terminal side of my angle of rotation and the nearest x-axis, is 40 degrees. My reference angle is 40 degrees, but my angle was given to me in radians, so I'm going to convert my radians, my degrees to radians by multiplying by pi over 180. You can do this with your calculator. I'm just going to do it the old school way. These will cancel. I can divide them both by 20. I can divide by 10, and then divide both of these by 2. Dividing by 10, dividing by 2 is the same thing as dividing by 20. If I divide this by 2, it gives me a 2. It gives me a 9, so that will be 2 pi over 9. So my reference angle in radians, 2 pi over 9, if I haven't made a mistake. The angle formed by the terminal side of the angle of rotation, terminal side, and the nearest x-axis. Don't be confused by this. This just, I know I had to go another 50 degrees, therefore the reference angle has got to be 40 degrees. And then I converted it back to radians. Hopefully I didn't make a mistake. I'll check my answers here in just a second. Let me scooch all this stuff over to the left a little bit, so I have a little bit of room to work. Oh, I didn't really help myself too much. But here we go. Looking at negative 11 pi over 6, I want to sketch this and then determine what the reference angle would be. 11 pi over 6, let's convert that to degrees real quick. These pi's will cancel. This and this will cancel. Divide this by 6, it turns into a 1. Divide that by 6, it turns into a 30. And 30 times 11 is 330, so it'll be negative 330. And now I'm going to rotate in a negative direction from the initial side, which is the positive x-axis. I'm going to rotate negative 330 degrees. That just means my direction of rotation is going to be like this. So here I go. There's negative 180, negative 270, and I want to get to 330, all right? And that will be 30 degrees shy of a full rotation. The full rotation, if I went all the way around, that would be a rotation of 360 degrees. So I stopped 30 degrees shy of that full rotation. That means this angle right here would be 30 degrees. And that is the angle we're looking for. The angle we're looking for is formed by the initial side, the positive x-axis, and the angle formed by the terminal side and the nearest x-axis. In this case, the positive x-axis is nearer to the terminal side of the angle than the negative is. And so this is the angle we're looking for, 30 degrees. The reference angle is 30 degrees. Run out of room there. The reference angle is 30 degrees. If we convert that to radians, we'll find that it is pi over 6. You can do that on your own and see if I'm right. And that is what we were asked for, the measure of the reference angle. Okay, so reference angles. Let me see if I've got my answer sheet, see if I got any of these right. I probably can't find it because that's just how the morning's been going. There's my answers for algebra, but this is not algebra, it's trig. I'm going to go out on a limb and say I have, oh, here's the answer sheet right here, yay. Let's see, 60 degrees, yay. 20 degrees, yay. 25 pi over 9 was 2 pi over 9. Is that what I got? Yay. And negative 11 pi over 6 is pi over 6, pi over 6. Yay. So those are all correct. We're finding reference angles. Remember, they're formed by the terminal side of an angle of rotation that's in standard position, meaning the initial side is the positive x-axis, and the nearest x-axis. The angles formed by the terminal side and the nearest x-axis. Reference angles. You can do this.